Okay, here's an example problem for some of the exercises you're going to be working on. This is problem number 70 from the set, and you're supposed to do B, C, and D. A says use Descartes' rules signs. We're going to not do that, so we're doing B, C, and D. Uh, so B, to list the possible rational zeros of F. You're not really solving anything here, you're just listing rational zeros. So for B, all you're doing is any rational zero has to appear in the form P over Q, where P is all factors of the constant term and Q are all factors of the leading coefficient. So unfortunately, they're the same. Just remember P is the last term and Q is the first term as long as you have them in order. So for 4, all the possible factors of 4 are 1, 2, and 4, obviously, positive and negative. And then for Q, it's the same number, so 1, 2, and 4. So now P over Q, this would be all the possible rational zeros. So you list all possibilities of these numbers over these numbers. So just do it systematically. 1 over 1, 1 over 2, 1 over 4. I'm going to start with 2. 2 over 1, 2 over 2, 2 over 4. And then with 4, 4 over 1, 4 over 2, 4 over 4. So an old probability trick to make sure you got listed all of them. If you multiply the number of factors for P and multiply the number of factors for Q, so 3 times 3, you get 9. You should have 9 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we're going to just eliminate. We're going to simplify and eliminate repeats. So this is 1, 1 half, 1 fourth, 2. That's 1, don't need it. That's 1 half, don't need it. We already have it. Then we have 4, and then 2 we already have, 1 we already have. So it's 1, 2, 3, 4, 5. But these are also all plus or minus. So usually I just say it could be positive or negative, all of these. So there's actually 10 possible rational roots. 1, 2, 3, 4, 5, the positives and the negative ones. So we're done with B. That's listing all the possible rational zeros. It's not really answering anything. If it does have rational zeros, and it might not, those are the only ones it could have. So zeros may be all irrational, perhaps. But anyhow, we're done with B. C says, now you would test these with synthetic division to see which work, but that will take a long time, and we're not going to do that every problem. So C says use a graphing utility to graph F so you can disregard some of these zeros. If you don't have a graphing calculator at home, use something like Desmos. But graph the function and try to see which zeros it goes through. And I can see it goes through these 2 zeros right here are fractions. So I could use my zero calculator and get them, but I think this one is definitely 2, and this one is definitely negative 2. So I think plus or minus 2 are zeros, and they will work through synthetic division. So that was part C. It's an easy part, but it's going to help you answer the question D, which is now we're going to determine all the real zeros. So again, we already know plus or minus 2 are going to work. So it's a 4th degree polynomial. So if we run it through synthetic division twice, we're going to reduce it to a quadratic, and then we can just use factoring to find the rest. So here comes part C. I know 2 is a 0, so I'm going to run it through synthetic division. Do not forget your zeros where they should go. So any missing term, fill in the blank with a 0. I should have 5 terms up here, one more than the degree. 1, 2, 3, 4, 5. I do. So now I'm going to go. According to my calculator, this is a 0, so I'm going to get ready to get a 0 there. 2 times 4 is 8. 8 times 2 is 16. 2 times -1 is -2. And 2 times -2 is -4. Perfect. The calculator also showed me that -2 should work. So I'm going to continue with the synthetic division. I know I'm going to get 0 right here. So 4 times -2 is -8. -2 times 0 is 0. And -2 times -1 is 2. So I do get 0. So I've already gotten 2 zeros, plus or minus 2. This is a quadratic. It's a second degree because the original was fourth degree and I did synthetic division twice. So this would be 4x squared plus 0x minus 1 equals 0. Now you can solve this in 2 different ways. You can add 1, divide by 4, square root, or you can factor. I guess I'm going to do it both ways because they're both pretty easy. I like factoring because you normally wouldn't miss a 0 that way. And this is a difference of perfect squares because 4x squared is a perfect square and -1 is a square. So it would factor into 2x plus 1, 2x minus 1. And then you can just say easily the factors are x equals -1/2. And the other factor is x equals +1/2. And if you went back to the calculator, that's what those 2 zeros are. So this looks great. I'm done. I just wanted to, if you didn't like factoring, I just wanted to show you how to you do it without factoring, and now I messed everything up. Here we go. It's getting away from me here. Hold on. Oh, there we go. So if you want to do this without factoring, because there's only one x involved, you can do that. You would just do inverses. It was -1, so I'm going to add 1. Next thing is to divide by 4. I'm going to divide by 4. Now here's where you have to be careful, and this is why I like factoring. You're going to square root both sides. When you square root both sides, you need to remember your plus or minus. Also, if the square root is simplifiable, simplify it. So if you have the square root of a fraction, you can take the square root of both the top and bottom separately. So I'm thinking square root of 1 over square root of 4. And the square root of 1 is definitely 1. And the square root of 4 is 2. So I still get the plus or minus 2, or 1/2 that I got up here. So to answer the question, my real zeros of this function are x equals 2 and -2 from the synthetic division and 1/2 and -1/2. It's a fourth degree polynomial and 4 zeros. That's not surprising. And that is it. It's not too bad.